Welcome back. One of the things that we have to make sure that we understand when we're talking about probability is the probability of compound events. That is, any event combining two or more simple events together. Calculating a probability of a single event is typically pretty easy. But when it comes to joining events together, we need to have some rules. So the first thing to know are the words and or. When we talk about the words and, we talk about the word and, we mean that we have two events, A and B. An event A occurs in one trial and event B occurs in a second trial, but both events must occur, right? So if probability of A and B occurring means that both events must occur for this event to be satisfied. On the other hand, the word or is often used when we talk about probability in a single trial, and in that single trial, event A occurs, or event B occurs, or they both occur. And it could be in separate trials, but in both either case, event A occurs, satisfies, event B occurs, satisfies, or A and B occurs, they both satisfy that event. We'll start with discussing our probability of A and B. And the words A and B are associated with events that are either independent or dependent. Two events A and B are said to be independent if the occurrence of one does not affect the probability or the occurrence of the other. If A and B are not independent, they're said to be dependent. Two events are dependent if the occurrence of one of them affects the probability of the occurrence of the other. This does not necessarily mean that one of the events is the cause of the other. Now, if we deal with another piece of this, we need to understand something called a prior probability or a given probability. Let me introduce some notation right here. The probability of B given A, we write as P, and then we use inner parentheses B and a vertical line followed by the letter A, meaning that probability of event B given that event A has occurred. How do we calculate this? Well, if the events are independent, then we can say that the probability of event B occurring is given A has occurred will just be the probability of event B. Since one doesn't affect the other, B is not affected. And of course, the same thing is if the probability of A given B would be the probability of A. The probability of A and B, therefore, would simply be the product of the probability of event A times the probability of event B. If the events A and B are not independent, right? If they're dependent, that means that to find the probability of A and B, we take the probability of event B and multiply that by the probability of event B given that A has occurred. And this is what we formally refer to as our multiplication rule. As an example, let's consider what would happen if I flipped a coin and pulled a card from a shuffled deck. What's the probability that I get a heads and draw a face card? Well, these two events are independent. One will not affect the other. So we can apply our probability rule that says that take the probability of A and B to be the probability of A times the probability of B. Well, the probability of flipping heads in a fair coin is going to be 1/2 or 0.5. The probability of event B drawing a face card from a standard deck of 52 cards, well, there are 12 face cards out of 52, that is 0.23. So the probability of events A and B occurring is just going to be the product of 0.5 times 0.23, which is 0.115. What if they're dependent? Here's an example. Let's say there's 10 pieces of candy in a dish. There are 5 pieces that are red, 3 that are green, and 2 that are yellow. If we choose 2 pieces at random without looking and without replacing the candy, what's the probability that both pieces of candy we choose are green? Well, first we're going to choose a piece of candy without replacing it. This will be green, right? Then if we choose our second piece of candy, we want to see what it would be like if that piece was also green. Well, in the first place, our choice is going to be 3 out of 10 for having green pieces of candy, right? So there's a 3 out of 10 chance you pick a green one at random. How about the second piece? Well, remember, we've just pulled a piece of candy from the dish without replacing it, so there's 9 left. And 2 of those would have to be green for this to be true. So that's the probability of B given A would be 2 out of 9. And so by our formal multiplication rule, the probability of A and B occurring is the probability of event A times the probability of event B given A. For us, that's 3/10 times 2/9. And that product is 6 out of 90, which is to say 1/15. And so the probability of getting green twice is 1 out of 15. To apply the multiplication rule, we should think about a little bit of a system. First of all, we should always assume that 2 events are independent unless we can show otherwise. But if the events are independent, then we can use our rule where we just simply multiply the 2 probabilities directly. But if the 2 events are not independent, that is, if they're dependent, then we must use the formal multiplication rule, the probability of A times the probability of B given A. Very often, when we apply independent probabilities, we can use a graphical method called a tree diagram to help us work out what that probability is going to be. Let's get an example here. Let's say that I have given a test with 2 questions on it, and nobody knows the answers, but they're going to guess. So this figure summarizes the outcomes. We've got 2 questions, and if one event does not impact the other event, our choosing a true or false does not impact whether we choose A, B, C, D, or E in the next question. We could say that, well, if in our first question, if we choose true or false, there's 2 events that could occur there. And then in the next event, I guess from A, B, C, D, or E, there are 5 events. I would have a total of 10 possible events. So just simply guessing the answers correctly to both questions on my test would be 1 out of 10.